Hello, this is Gene Jones. I'm with the Southern Waste Information Exchange. I'm going to talk to you a little bit about agricultural film mulch collection and recycling and an overview of some obstacles and opportunities that are faced within this subject matter. I've been working on it since approximately 1999 here in the state of Florida, when I was asked to do what's called a technical advisor group meeting for the state to look at why agricultural film mulch really hasn't been a sustainable recycling solution, and what are the problems associated with it, and how can you overcome that. So hopefully this presentation will provide that overview for you. The mulch film itself is basically used here in the state of Florida in the growing of tomatoes and strawberries. There's roughly about 35 to 36,000 acres of tomatoes and another 5 to 6,000 acres of strawberries. The amount of material that is generated equates to roughly 20,000 tons of mulch film annually in the state of Florida. It's managed in a number of different ways. The way the film is removed, it's typically pulled by hand. As evident in this slide, you'll see the worker pulling the film by hand. And at that point, they will either drop it straight back down or pile it up. As an example of the material being pulled by hand and then set in little piles. And from that standpoint, it is then either landfilled. We have a couple of landfills here in the state of Florida that have set up what are called monofills. So this view that you see, this raised bed that you see in the background, is actually a monofill of nothing but agricultural film mulch. This is in Collier County, Florida, and Immokalee, big area for growing of tomatoes. And there's roughly about 55,000 tons of ag film mulch buried at this one location. The other way that it is handled, there has been some export of the material. And so what will typically happen is the material is baled in the field. This is a tobacco baler, and the farmers in this particular instance have used the tobacco baler to bale the film, compress it in the field, and what looks like a nice bale of plastic is far from it. This particular bale weighs about 1,500 pounds, and it's roughly about 70% soil. It's hard to imagine that, but I'm going to show you some slides here in a few minutes that'll demonstrate that. I've worked on a project where we tried to enhance market development here in the state of Florida. So I've helped farmers compile the material out of the field, and then we have sent it to a number of different locations. I've sent film to Vietnam, Malaysia, Mexico, both places, Romania, and several places here in the United States to figure out if we can't recycle the material. The other way it's managed is there's some pretty large agricultural stockpiles that are piled up around the state. So you have some farms that have basically thought that, there's at one point this is going to be recyclable, so we'll just set it aside until we have a time where somebody really wants the material. So you've got some pretty big piles growing up around the state, as I said. The problem with once you start getting it into piles is vegetation is going to grow in it. Here's a good example of that. So it becomes very problematic. Even if a recycling option is available, you're causing more problems. With the intention was good, some of these farmers, but the problems are developing here by this instance. The other way that it is managed in Florida, and this is kind of hard to imagine, but it'll be piled up in little piles, and the farmers will add a little diesel fuel to it and burn it. And what is left is an example here. If you've got a burnt pile of ag film, and this is really just volume reduction for the farmers. They're trying to reduce the amount of material that they have to handle. So they'll burn it in the field and then deal with these piles of burnt ag film and haul it off at that point. The other way that it is burnt in the field, and I'm going to show you a quick little video of an automated way. This is actually a unit that hooks up to the back of a tractor. It's just a propane tank that hooks up to the back of the PTO of the tractor, and then they just haul it around from site to site. Very useful in burning of the polypropylene twine that keeps the plants up, but it's also used, if you can see, they've got two down burners that actually burn the film. This is the residual after they use this technique to burn the film, and then that plastic would then be plowed into the field at the end of the growing process. The obstacle is soil. Here's an example of a photo of some shredded plastic. You can see the soil that's incorporated onto that film. I wanted to see it firsthand. I've always heard people talk about the volume of soil on agricultural film mulch, and it's kind of hard to imagine because it looks like all plastic, but it's not. And so what I ended up doing is taking a sample of film. This is roughly 16 ounces of film that I collected from a shredding process. And we went ahead and washed that film. And so I did a triple rinse process where we separated out, started on the far left-hand side as you're looking at this slide, and moved it to the next batch and then the next batch. What you're seeing there in the bottom of those first two units is I've added a little flocculant to the water itself to help drop out, similar to what you would do in a pool, drop out those solids that are involved in the water. So the sand and the soot, what I call microdust, accumulates at the bottom of that. From there, I just boiled off the water and was left with the sand and the dirt, and then we strained out the plastic and dried it. From there, we weighed the plastic. So this is the clean plastic, and as you can see, I've got 4.16 ounces of clean plastic. I had 8.46 ounces of sand, and then we had roughly an ounce of what I call microdust, and I'll show you some example of what that is. So total sample weight, 16 ounces. Net plastic after cleaning was 4.16 ounces, or 26%. So we had a soil contamination and moisture contamination of roughly 12%, 74%. And below was the breakdown between the sand, the soil, what I call the microdust, and the estimated moisture. If you look at agricultural film mulch under a microscope, this is a view of virgin film has not been laid on the ground. You'll see a micro pattern woven into the plastic itself. This is to provide rigidity and strength to the plastic, so when they stretch it over that mound and then tuck it up underneath the ground, the plastic doesn't tear. The problem with it, this is the same film. It has been laid on the ground and then pulled up after a period of time, and here you can see that micro pattern is still there, but it's disappeared. And it's disappeared from the standpoint that microdust that I was talking about. Little square area kind of acts as a suction cup. In addition to that, there is something going on from electrostatic charge where soils have a negative charge and the plastic, I believe, has a positive charge. So you're having the soils adhere to the plastic. What you also see here in that top portion of the slide, that crystal looking item up there is actually a grain of sand. So that tells you how small those micro patterns are on the film. Another microscopic slide, these are sand granules. And then this slide demonstrates the microdust. The upper portions, like right up in here, this is actually a granular of sand. So in this area, this is the microdust. So that shows you how small that material is. The opportunities that exist in this area, I think the first thing you need to try to do is to remove the amount of soil in the field. And so we've worked on harvesting technology to pull the film out of the field and leave as much soil as we can in the field. And that's done through, I think, a combination of the technology as well as the methodology of how that film is pulled out of the field. What we've done is develop a process where we pull the film up either by hand, or we have some automated processes, which I will show you. We leave the film on the ground for a period of time to allow air to get to that moisture that's on the bottom of that film and allow it to dry. Once you do that, you give some residence time in the drying of that moisture that's on that film, and you start moving that film after that point, a good bit of the soil actually falls off. And I'll show you some demonstrations. So this particular unit, we're rolling film out of the field. We're rolling multiple rows at a given time. And it creates what we call a tight spool. And so you can see from this picture that the material looks very tight, very clean comparatively to some of the bales of material that you saw in some of the prior slides. Another thing we have done is developed equipment to actually roll the film from the end of the row as opposed to going down it. And this is an example where you can actually source separate out the drip tape from the ag film mulch. By doing this, you're actually increasing the value of the product, especially the drip tape, because it demands a higher price from a recyclability standpoint. We talked about a little bit about rolling the film, letting it, this is probably a good example of us letting it lay in the row and allowing it to dry and then coming back and rolling it. I'm going to show you a demonstration here of a video where we're rolling actually 800 feet of film at a given time. And what happens is, you'll notice from the slide in the video here, actually a little bit of friction activity going on, what I call friction clean, where we're moving that film across the field, and by vibrating that film, you're helping the soils dry off. So let me show you that. We rolled that 800 feet in about 20 seconds. Also worked on technology to pull the film out of the strawberry field. So here's an example of this piece of equipment. What we're doing is basically splitting the row. So there's a cutter in the front behind the tractor, and then we're pulling the film up out of the ground and then laying it back down. Again, the methodology here is to give that film some time to dry before we start rolling it up. Here's another example. This is a different technique. This is actually a rolling process. This was a test trial on a zucchini farm in South Georgia. This piece of equipment hooks up again to the back of the PTO on the tractor. And we'll pull in, not over the row, but off to the side. You can see the amount of soil, sand that's flying off of that film. Where the future brings, I think, is the recycling advancements are key. You've got to reduce the soil in the field. Mainly, the main reason for that is that you're going to lower the wear and tear on the recycling equipment. And the other thing that I think is going to happen with some of the fuels or the film, if you can't go in traditional recycling operations, there's a huge potential here for alternative fuel for the cement industry. The films have tremendous BTU value, British thermal unit value, and that film burns much cleaner than coal. About 95% of the cement kilns in the United States operate off of coal. And so a lot of the cement plants have an interest to replace some of the coal that they're using with alternative fuels. And if anybody has any questions, please contact me via my contact information here.